My fabulous chemistry minions, video number 5, going to get into unsaturated hydrocarbons now. These are the guys that are still straight chain, so we're going to keep it simple, but we're going to add a wrinkle. So there's going to be a double bond or a triple bond that makes it so we can't have as many hydrocarbons. Now, same learning target for video 4 as 5, so there's going to be one combined, what do we do at the end? Reflection. Right? One reflection at the end for both, so probably double points. But anyways, double, triple bonds. Here we go. Unsaturated hydrocarbons have a double or a triple bond right off the bat. And this uses up extra bonds now between the carbons, which means there's less room for hydrogen. I want you to look at the picture at the bottom of the screen and ignore the part where there's the O double bonded to a C to an OH. Forget about that. Look at the big chain piece. And the top one says saturated because all the carbons are all single bonded and it's holding a ton of hydrogens. And then notice on the bottom one it says unsaturated, and in green highlight there's a double bond between the carbons, and notice there's some hydrogens missing. Okay, that is what we're talking about with unsaturated. There's parking spots there that are empty that I could put hydrogens. Okay, this is the way I like to think of it. I'm going to get right into the naming of these alkenes because it's going to follow some of the very, very similar steps that we learned in video 4. And these, all those steps from video 4, we're going to use for everything we do. Okay, so they're going to keep coming up and up and up. So first, right off the bat, prefix, how many carbons? The first thing I ever want you to find out is how many carbons. So let's go ahead and count them. 1, 2, 3, 4, 5 carbons. 5 carbons is a pent. So I know this thing is going to start with pent. Okay, now I need to get to the root. The root comes from table Q, and it talks about what kind of bonding is present between the carbons. So let's have table Q. I look and I see a double bond between the carbons. The rule is any single double bond makes it now an alkene because I see a double bond in between these carbons, and that's alkene. So this is going to be pentene, not pentane. Notice one letter difference between pentene and pentane, and it means all the world of difference in drawing these molecules. Pent means 5 carbons, ene means there's a double bond. Now for the rule that's going to take a little bit of time to make sure we understand. The rule says I need an address, a number in front to tell me where the special part is. The special part is double bonds, functional groups, or side chains. These are special parts or deviations, something that's different than just a single bond alkane. Tell me where it is. So we need to follow a simple rule. The lowest number always wins, so you need to count the carbons in both directions. So I purposely chose this example so I can show you what I'm talking about. Okay, I'm going to recount the carbons. 1, 2, 3, 4, 5. And when I look at these carbons, this double bond is on the third carbon or after the third carbon. Good. So that would be 3-pentane. But until we get good at this, I want you to do this all the way out. I need to count the carbons from the other direction now. 1, 2, 3, 4, 5. Notice I changed colors. When I count this way, isn't that double bond now after the second carbon? So if I counted this way, it would be 2-pentene. And then the rule is lowest possible number wins. So it's not 3-pentene, it's 2-pentene. And I have a little model here to show you what's going on. Now, I don't know which way you see it. Okay, because you might see it left to right or right to left based on how this thing is videotaping. So I'm not going to try to do that. I just want to show you that when the way I'm looking at it, I would count 1, 2, 3, 4, 5, and that's what I did in the first instance. And hence the carbon number 3 is where the double bond is. Okay, and if I count from the other direction, 1, 2, it's at the second carbon, and this is what the process I need you to do when you're drawing it. But here's the reason why. If I count from this direction, 1, 2, 3, the carbon, or it's at carbon number 3. But watch, if I just flip the thing over and count from the my left again, 1, 2, oh, it's on 2. But did I change the molecule any? I mean, did I change the molecule any? Did I change the molecule any? No. So these things are allowed to move around in 3-dimensional space. And yes, these are the kits that we're going to use for the model or for the lab. And so the rule has to happen that we pick the lowest number, because if I just turn this thing in space, I haven't really changed the molecule one bit at all. All I did was rotate the thing, and now it's on the second carbon. So I have this rule in place. There is this rule in place. It's not a Milk's rule. It's a chemistry rule. The rule is in place so that I can draw it forwards and backwards properly every time. Now, when you were to draw this thing from 2-pentene, you would probably put um, the the spot on the second carbon. Now I just highlighted that with my mouse, and I don't know that it shows up. Uh-oh, Spaghettios. Ruin the video, Milks. Okay, so I just want you to see in this molecule why we have to always name it at the second carbon. Now, if you draw it like this, it's still 2-pentene. And if I draw it like this, it's still 2-pentene. So you can actually draw it either way. I'm going to let you know that we generally go from left to right. So from my left to my right, and I don't think it's that way for you, but I'm going from left to right. I would drawing it would put the carbon or the double bond on this carbon, and that's good, and that's what I'm expecting you to do. I'm just letting you know you wouldn't be wrong if you drew it this way. You just have to count from the other direction. They both work, and this thing is designed so we can go backwards and forwards. Lowest number. That's why it's lowest number, so I can go backwards and forwards and draw the right thing. Okay. Now I'm going to get into some ynes. I'm going to get through some more examples so we can get on with this because I'm taking too long. And I don't have an yne done for you. I only have an ene. Again, prefix tells us how many carbons. 1, 2, 3, 4, 5. I don't think I'm going to actually count them out and show you it's a pent. So we're getting good at this now. I can count the carbons without me putting up the little red numbers. Then I'm going to look at what kind of bonding is present, and I see a triple bond present. So when I see a triple bond, I'm going to go to the table Q, find the picture with a triple bond, and look that it's alkyne with a Y-N-E-S. We call that yne. So this is a pentyne. Then I do need to count, and I'm going to do this for you. I believe it's going to come up. We need the same deal. The number in front tells us where it is. So I have 1, 2, 3, 4, 5. The triple bond is after the second carbon. If I count the other way, 1, 2, 3, from my right to my left, it would be at the third carbon. So 2 is lower than 3, so 2 wins. Okay, I just counted in my head both directions without actually putting it on the screen for you. So yes, I hope you're listening. So 2-pentyne is what the correct name for this. So now you have a few examples for each. Oh, and then there's the general formula. So the general formula, notice, changes. For alkenes on table Q, it's CN2N. And for our alkene notes, C5H10 fits that description of 2-pentene. So if you just get C5H10, you plug 5 in for N, and then figure out which combination, 2N, 2N plus 2, or 2N minus 2, gives you 10 when you have 5 carbons, and then you'll see that that lines up with alkenes. And so if you get just the C5H10, you can figure out just from there using this generic formula that it is a double bond somewhere. Same goes for ynes. This equation is CnH2n minus 2. So if I have 5 carbons, 5 times 2 is 10, minus 2 is 8. If I have 5 carbons, I should have 8 hydrogens. See how we did that? I wanted to do that before it came up just so you can see how we can do the math. If I see a formula of C5H8, plug in the 5, and then you have 3 H's to solve for. You have H2n plus 2, you have 2n, and you have 2n minus 2. These are all in the general formulas on table Q. Okay, and you can figure out, is it an alkene, an alkane, or an alkyne? Good. Let's do some examples. I got 4 for each, so it's going to take just another minute. I want to make sure that we all got this down. Same process. F tells me right off the bat 2 carbons, right? So I got 2 carbons. Bop, bop. And then I see ene. Ene is, I find the word that has ene in it, and that's alkene. Now I look at the bonding, it's a double bond. So what I need is 2 bonds between these carbons. Done. Now I have 2 bonds between the carbons. Now that I'm all set, at this point we're all set, just fill in our H's. And notice I do so in such a way that there are 4 dashed lines around each carbon. That's part of the initial rules we wrote. And if you cover up one carbon in the picture, you can see that there's 4 dashed lines around the carbon on the left, cover up the carbon on the left, and there's 4 dashed lines around the carbons on the right. That's how I get to figure out how many H's, right? Molecular formula, count them up. I got C2H4. That is now unsaturated. Notice there are parking spots. Moving right along, I got prop. Prop tells me that there are 3, count them, 3 carbons. Bam. Then I got an ene. Ene tells me that there is, using table Q, alkenes have a double bond. So now there's a double bond. There we go. And with just prop, I don't need to tell you a number because it's always on the first carbon. Even if I were to move it over there, if I rotated the thing, it'd be back to the first carbon. So I don't need a number on props. I don't need a number on Fs because there's only one place it can be. Okay. Fill in my H's, count them on up. I have C3H6, and it is unsaturated. There's a lot of room. There's 2 spaces for hydrogens there. If this was saturated, there would have to be 8 hydrogens, 2n plus 2. Okay. Now the numbers are going to come into play here on 1-butene. But tells me that there are 4 carbons. So, okay, let's get 4 carbons. And then ene tells me there is a double bond. So alkene, double bond. But now I got to figure out where to put that double bond, don't I? Well, that's what the number's for. I have to put it on the first carbon. Now, when I'm drawing these, I read from left to right, so it's natural for you to put it there. Okay? And I know the font changed, but that's just how these pictures worked out. So that I put the double bond on the first carbon, and then I just fill in my H's. And notice how when I go from here, how many H's I could put, to here, how many H's I could put, there's less H's available now. Fill in my H's, and we got this thing down. So this is 1-butene. The bottom H on the first carbon can go on the bottom or the top, by the way. You'll see that when I draw these, I instinctually notice on either side of the double bond, the H's are both down. When I'm drawing them by hand, I would do one down and one up. There's no wrong. I'm not upset how you draw them. There's really no right or wrong at this level of chemistry for how we do that. Okay. As long as you have the right number of bonds around each carbon, you're all set. Okay, so this again is unsaturated. Counting them all up, I got C4H8. Okay, and then I have the next example. This one I'm given the picture, and I got to come up with the name, and I know ahead of time this is going to be very similar to the one we just drew. 4 carbons right off the bat, going backwards on table P, go 4 carbons, find but. There we go, so this is going to be a but. Then I look at the double bond. I know it's got to be a butene. I find a double bond in my reference table, find it's an ene. So this is butene. But now where on earth is that double bond? It's on the 1,2 carbon. And either way I count this, left or right, it's going to be on 2 carbon. So carbon number 2. So this is 2-butene. Notice the difference. There's a 1-butene and a 2-butene. And notice there's a difference in the structures you have drawn now. And that's where I'm hoping it's starting to click. The number or the address tells me where the deviation is. The deviation of ane is ene. Okay, and notice the molecular formula now is going to be the exact same. It's going to be unsaturated, and I have 2 molecules now, C4H8, with different structures. One's 1-butene, one is 2-butene. How do I know there's different structures? They definitely have different names. That's preface to what's coming up in 2 videos from now. So I just want to make highlight of that. You're going to see that again here in this one. So let's get done with ions, and we can call this a video and get you on your way. F, same process, going right to how many carbons? F is only 2. Bam, got 2 carbons. Now I'm dealing with yne, Y-N-E. Find my yne. Yne means there's a triple bond between the carbons. So I need to add 3 carbons. So this is why when I'm drawing these things, these pictures have all 4 bonds on the carbons. I only put the bonds between the carbons when I draw the backbone, by the way, and then I do all the other bonding. Fill in my H's, and I have ethyne. Ethyne, C2H2, is unsaturated, and we'll see that that is 2n minus 2. 2n, 2 times 2 is 4, minus 2 is 2. An yne is going to have 2 hydrogens. See how we do that? Nice. Prop, 3. Prop is 3. I'm getting good at this. It's starting to come into my memory, but these videos are nice and good and long and dragged out to make sure that because we are not doing this together live, you get a nice, thorough description of what is going on. Ynes, triple bond, present. I see ynes, I see triple bond. I need to put it in there somewhere. And on a prop, again, it doesn't matter which carbon I put it on now. It's got to go between carbons, and it's always going to be on carbon number 1 because it doesn't matter how I draw it. Count it forwards and backwards. If you put it on the other side, it'll still end up being on the 1. Fill in my hydrogens, and we are done. So this is C3H4, 2n minus 2. 2 times 3 is 6, minus 2 is 4. Matches unsaturated. Got it. Now, 1-butyne, here we go. Bute, 4 carbons. Okay. Bute is 4 carbons, so let's do that. Then ine. Ine tells me, and I'm being very, very right, painstaking with this, but I want to make sure it's solidified because these are your notes. I need a triple bond. Where do I put it? On the first carbon. Bam. Here we go. Now fill in my hydrogens, and there we go. I have a 4-carbon chain with a triple bond on the first carbon. Done. This is C4H6, and again, it is unsaturated. There are 4 empty parking spots. Those 3 bonds are making it so I could add 4 extra hydrogens. Okay. Now, next one. 1, 2, 3, 4 carbons. Again, that's going to be another bute. So I got that. And then I look at that triple bond, even 1 triple bond, and that's an ine. Okay. That's butyne. But where is that? It's on 1 carbon number 2. And either way I count it, from the left or the right, it's still on carbon 2, so 2 wins. 2-butyne. Okay, good. C4H6. Notice, again, this molecular formula is the same as 1-butyne. Same molecular formula, different structures, different names. So molecular formula doesn't give me all the information. Where the structural formula does, the name does, and we have a definition of what these things are. These are called isomers. This is coming up in video 7, I believe, after we do side chains, because then we'll be able to move bonds and move side chains to create isomers, okay, by definition. Now, straight chain hydrocarbon summary for unsaturated. Number of carbons, still my prefix. Bonding is between my carbons is my root, but then I need the number in front to tell me where the multiple bond is. So I call that the address. Tell me where it is. Now, there's one thing I did not cover in this whole thing, and it might show up in the practice. So there's a prefix di, and we know di means 2. It won't work for the CN H2N. Those generic formulas don't work if there's more than 1 double bond, but we could have 2 double bonds. 2 double bonds would be a diene, and 2 triple bonds would be a diene. So it would be butadiene or butadiene. Or if I have 2 triple bonds or 2 double bonds, and it would just change the amount of hydrogens I would have. But I just wanted to throw that out there that I could have more than 1 double bond, and then I would have to put a di in front of the ene or the ine to show me. And I believe that comes up in the practice, and we'll probably do that in class together. I just want to throw that out there because it didn't come up in these examples. And with that, I know it's been a really long video, but we are done. Okay, good luck with your practice, and I'll see you guys in class.